Hello, welcome back once again. Today we're giving another interesting geometry problem. As you can see, a straight line with two identical circles on it. We're given this red square right over here. And what is the question? We're here to solve for the area of this red square. So let's get started. We can see the radius of each circle here is 5 meters, right? Now let's think about drawing this line from the center of this circle to this point on this arc. So we know this line is also the radius of the circle, which is also 5 meters long, right? Now, let us extend this length from here to this place, okay? Now, if you call each side of this red square x, then this length of this place is going to be x, right? Don't forget that the total length is 5 meters long. Therefore, the remaining part here is going to be 5 minus x. Cool. Now, let us draw this line, which is going to be tangent to both circles. So, from this down to this place. Okay, so we can see this line divides this red square into two equal parts. Remember, each length or each side of this red square is x cm, right? X meters, I mean. So each length after dividing this is going to be x over 2, and this is going to be x over 2. Now, don't forget that if you draw this line from the center of this circle to the one of the vertex of this red square, that is going to be the radius of the circle, which is also 5 meters long. But don't forget that we have this length from here to this place, and we can see that this is x over 2 right over here. Therefore, this length from this place is going to be 5 minus x over 2, right? Now, we're going to concentrate more on this right triangle right over here, which we're going to use the Pythagoras theorem. Now, let us think about the following. When you have a right triangle, let's say this length here is A, this length here is B, and this length here is C. If you use the Pythagoras theorem here, it is going to give us that A squared plus B squared is equal to C squared. Now, let us bring out the right triangle which we have right over here. So here is a right triangle. So sorry for that. So we can see that the adjacent here is 5 minus x over 2. The hypotenuse here is 5 meters long, and the opposite side here is 5 minus x. So we can see this is 5 meters long from this diagram right over here. Okay, now we're going to use the Pythagoras theorem. If you use the Pythagoras theorem here, we're going to have the following: that 5 minus x whole squared plus 5 minus x over 2 whole squared, this is equal to 5 squared. Now, if you expand this, we get 25 minus 10x plus x squared. So if you expand this one here, we get plus 25 minus 5x plus x squared. So this is equal to 25. Okay, so from here we can see that 25 on both sides. We have 3 25s, 2 at the left hand side and 1 on the right hand side. And the 3 25s are all positive. So we can just cancel out 125 on the left and 125 on the right. Then simplifying, we get from here, oh, this is x squared all over 4. I'm so sorry for that, right? Because x over 2 squared will give us x squared over 4. So if we add x squared plus x squared all over 4, that is going to give us 5x squared divided by 4. And then negative 10x minus 5x is giving us negative 15x, right? And then we have plus 25 and this is equal to 0. So if you multiply each time from both sides by 4, we get the following: 5x squared minus, that will give us 60x plus 100 is equal to 0. Now divide both terms from both sides, or each term from both sides, by 5, then we'll get the following: that x squared minus, that will give us 12x, and then plus 20 is equal to 0. So if you use the general quadratic formula to solve this, or if you use the factorization method, we know this is going to be x minus 2 multiplied by x minus 10 is equal to 0. So from here we get x is equal to 2, or x is equal to 10. But don't forget that x is actually less than the radius of the big circle, right? But the radius of this big circle is 5 meters, right? Therefore, x is equal to 10 is extraneous. We have only one possibility, which is x is equal to 2. And this x is the side of this red square. Don't forget that the area of a red square there is going to be x squared, right? Therefore, the required area is going to be 2 squared, which is 4 meters squared. This right over here is our right answer. Thank you for watching. If you enjoyed the video, kindly subscribe, also like, comment, and share.